Hey everybody, Bill Sky, the C++ guy, and we're going to continue our discussion on pointers. This time we're going to talk about different types of pointers other than just integer pointers, and also arrays and how pointers and arrays relate to each other. So let's get started. So this is basically the same project that we were working on in my first pointer video, which I actually have in the description of this video. And I wanted to do a couple other things with this project than just doing integer pointers. And if you remember, that's pretty much all we did. We created an integer, we created an integer pointer, we showed how an integer, you can get its address by putting an ampersand in front. You can also assign that address of that integer that is referring to memory into the integer pointer, and then you can use the integer pointer just like the regular variable by dereferencing it with an asterisk. But can you do that with different data types? Well, of course you can. Any basic data type, any class, any data structure, you can create a pointer with it. So for instance, if I have a double called, I don't know, my IQ, and I make that equal to 135.22, can I create a pointer that points to that variable? I certainly can. I can say double asterisk, which means it's a double pointer called my double pointer. That can be equal to the ampersand my IQ. Now my double pointer will behave just like my IQ. So I can say count my IQ. I can say count my double pointer. Or I can say count dereference my double pointer. Now, you should look at this and say, well, what is each one of these statements going to do? I'll give you a second. Second's up. This will print the value 135.22 because it's a regular double value, double variable. This one right here, will it print the 135.22? No, because my double pointer contains the address of that 135.22 that's in memory. So it will print the address. How do you get it to print 135.22? You say asterisk my double pointer, and that asterisk is the dereference. So let's go ahead and build that and run it, and let's see if that's what happens. All right, there's our 135.22. When I count my double PTR, it prints out this very ugly hexadecimal number, which is the address of where the 135.22 is stored. And then if we dereference it, there's our 135.22. Now something special about, in this case, a double pointer is I can create another double, and I can assign any double, the address of any double, to that my double pointer. So I can say my double PTR equals ampersand my wife's IQ. And then I can print my wife's, oh, no, my double pointer. Save and build it and run it. And there's your 143.99. So any double can have its address put into a double pointer. But can we mix those? Like I've got a double pointer called my double pointer. Can I say my double PTR equals to, and what was the integer? And int. So can I say ampersand and int? You think that'll work? Taking bets right now? Betting is closed. Let's take a look. It won't even compile. It says that it cannot convert an integer address and put it inside of a double pointer. Now there's ways around that, but you don't really want to do it because a double is a floating point. It uses a completely different part of the CPU, and you don't want to mix apples and dinosaurs. I mean, that's how different they are from each other. And if you want to take a look and find out exactly how a floating point is stored in memory, you'll see it's totally different than an integer. And you can see that in my assembler language series. I haven't yet recorded it. at the time of the recording of this video, but it will be out there maybe in a month or two. So they are completely different. So no, you cannot mix those. What about creating a char? Can I create a char pointer? I don't know why not. And then I can say char middle initial. And then I can say char ptr equals ampersand middle initial. Remember, the ampersand returns the address of that. And then I can say count dereference a char ptr. Now I had to comment this out because the program will not compile if I don't. And if I run this, we should see a J. And I can always print what is the address of that by simply counting and don't dereference a char ptr. Now it'll print what's inside of a char ptr, which is an address, and that address is where the J is located. Now this looks kind of weird, and that's because the characters that... Oh, I know why this is weird. This is weird because a char is a little bit different than any other pointer. A char pointer actually is a pointer to an array. So what it did was it printed J, but it also printed some funny characters until it got to a 0 in memory, a null pointer, a null character, I should say. So a char is a little bit different. And we're about to talk about arrays, so this is kind of a good segue. But you can create a pointer to any data type. Any data type. I mean, even if I had a structure, I'm going to create a structure called, I don't know, zombie. And I can have an integer, days dead. I can create a, I don't know, string, name. I don't know, just silly things, right? And then what I can do is I can create a variable called zombie x, and then I can say zombie pointer, a zombie ptr equals ampersand zombie x. And I can access the data just like I would in a regular variable. Now for zombie x, I would say zombie x dot, and I would specify the name equals scary zombie. So you would use the dot. However, if I wanted to use the zombie pointer, I would say dereference a zombie ptr dot, and notice what Eclipse did. It changed it to a dash greater than. So when you're dealing with a pointer within a structure or within a class, you use the dot greater than. Now Eclipse will do that for you, and I'm going to say days dead 92. And then we can say count a zombie ptr dot name, a zombie ptr dot days dead. And let's say how that builds. Now this is a little bit weird because what's happening here is that it is looking at days dead before dereferencing the zombie. What you want to do is you want to put that in parentheses like that. So you want to dereference it. Let's see what happens. You still have an error. So then you put the dot there. And this is all about just syntax and how you would do it. So what this is doing is this is first saying dereference the zombie. So it's no longer a zombie pointer, it's a zombie. And then you can use the dot nomenclature, or the dot syntax, I should say. So let's go ahead and, oh, now wait a minute. Now we're going to have to dereference this to get that zombie data. Remember, we have to dereference it, otherwise it's just going to give us a pointer. And I like to do copy and paste quite a bit. So you always want to dereference the class, or the object, or the structure before you actually get the data out of it. So I can make a pointer for anything. And it also depends on the type of If it's an abstract data structure, you have to dereference it first before you access it, just like we showed here on line 56. Okay, so I mentioned arrays a little while ago. First of all, remember an array, right? If I make an integer array called my int array, and I make it of size 10, or let's make it of size 5, and I'm going to put some numbers in it. All right. So how do we print the contents of that array? Well, can I do this? Can I say count my int array? I just absolutely love it when students, first semester students, ask me, why can't I just print an array like this? I mean, in Python you can, but remember Python is an interpreted language, so it can do things differently than the CPU does. Let's see what happens when I run it like that. Are we going to see the values of the array? No, we're going to see an address. Huh, what does that sound like? That sounds like a freaking pointer, man. So my int array is actually a pointer. Whenever you create an array, you're actually creating a pointer. So if I'm doing that, look what else I can do. I can then say, what was the name of my pointer up here? An int ptr. Let me copy that. So I could actually put the address of my array, copy that into an int pointer, and then I can say an int ptr of 0 and int ptr of 1, and so forth. So the pointer variable, because a pointer is an array, or I should say an array is a pointer, it works just like an array. Now, if I wanted to do something kind of cool here, I could say for x in an int ptr out x. Let's see if that'll work. I don't think that syntax is correct. I think that syntax is more like for Python. So on C++, you have to put a parenthesis here where you say x and ptr. There's no colon. Let's see how that works. Oh, got to say for, now you could say for int x, or you could say for auto x. I'm just going to say int x because I know it's an int pointer. And this is one of the things about C++ 11 and above that is a little bit irritating. The syntax of this is correct. The problem is that the preprocessor does not see that as an array. Even though it is a pointer to an array, the preprocessor doesn't see it as an array, so you can't use it in a range-based for loop. However, if I want to just go ahead and change that to the array name, now the preprocessor saw that as an array because it said, oh, that they defined that as an array, and we're going to go ahead and treat it as such. But you can use the integer pointer and int pointer just like an array, as you can see in that example. It just doesn't so much work with the range-based for loop. And that's pretty much what we just did in number 4 that I wanted to go over, is to show how an integer pointer, you can have it as a double pointer, you can have it as a long pointer, a char pointer, you can have it as a short int, you can have it as an unsigned, it doesn't matter. You can have it as a zombie for that matter. I can create an array of zombies and I can access it in exactly the same way. So that's a little bit more on pointers. We talked about different data types for pointers. We talked about how an array without the square brackets is just like a pointer of that same data type, and how you can use a pointer of that data type for an array pointer. So after this, the next video, now I promised this on the last video, but I thought we needed to do some more stuff on pointers before we moved on. So hopefully the next video is going to be on dynamic memory allocation and how pointers can be used for that. Hope to see you there.